Okay, so how many of you were able to at least get this far and say, okay, we definitely took, this is the parent function, we went right 3 and up 2, correct? Were you guys about there, right 3 up 2? So then and it was kind of hard to tell from this, but there was no stretch or compression, there was no factor multiplied in front to make it greater acceleration or less. So the only shifting was right 3 up 2. A lot of you remembered that it was an opposite shift, so we knew our new function would be from the parent function, it shifted right 3, so that's x minus 3 cubed, and then up 2, plus 2. So it's been a long time since you've done transformation, so I didn't expect you to get 100% correct. It was just trying to see where you were at. Does everybody understand now? Kind of remembering, oh yeah, it kind of looks familiar. Yeah. Okay, awesome. We're just going to be doing more transformations with polynomials. So everybody, understand a couple things. The graph of the function, y is equal to a times the function. So this f just means it can be any function. So we're going to extend this to all functions. A times f of x minus h plus k is a vertical stretch or compression. Oh, sorry. It's going through and telling you what each thing is. So this A is a vertical stretch or compression. So I said that A is a vertical stretch or compression of the function. That's what's multiplied in front of the function. It's a stretch if your A value is greater than 1. It's a compression if your A value is less than 1. Now think about it. If I take something like, I like to show quadratics just because they're easy to see. If we have let's say a normal quadratic with no stretch or compression. If I take and make the acceleration greater, won't that be going up quicker? Everybody? Right? So it will look something like this a little bit more. Do you see how that stretches it this way? It's a vertical stretch, right? Is everybody understanding? And then if I make the acceleration less, it's going up less fast, so it's going a little bit slower, so it looks more like this. So do you see how that's taking and compressing it down? I'm like drawing smiley faces. So that's a compression. So if A is just 1, it's not a stretch or compression. The f of the x minus h is your horizontal shift left and right. And you always go opposite of the sign with horizontal shifts. I'll give you a brief explanation of why, but we can't get way into it today because it's a short day. And then the plus k, anything added to the outside of the function is your shift up and down. And you go with the sign. That's just taking the function, shifting it up or down. That's why the sign stays the same. Now, that negative in front of the function is a reflection. And there's 2 types of reflections you're going to see. If it's negative 1 times the function, then that is a reflection over the x-axis. And then if it's f of negative x, if they're plugging in a negative x, that's a reflection over the y-axis. Now, here's why that is. Everybody, if we're reflecting over the y-axis, look at these points. If we're starting here and we reflect it over the f of x-axis or the y-axis, won't we just be plugging in negative x? But we'll still get f of x, right? Everybody, do you all understand why? And then if we want a reflection over the x, it's the inverse of the function. Sorry, the negative 1 times the function. So that would put it down here. Does everybody see that? Everybody good with that? Okay. So if negative a is in front, you only look at the absolute value of a for the stretch or compression because the negative is what reflects it over the x. A lot of people will forget that. Does everybody have those shifts down? Are we good with those? Do you need to take a picture of it? Are we good? We're all good? No? Speak up, people. What do you want me to do? Are we good or not good? Okay. Does anyone care why it's opposite? If not, I'm not going to spend time. You guys all just, are you okay with it? I'm okay with it. If you're okay with saying yes, it's fine that it's opposite. Yeah, I mean, you can think of it like that. Does anyone care enough for me to go through it? Not really. You can be honest. It doesn't hurt my feelings. We can move on. Nobody is bugged by it? Sweet. Okay, awesome. So let's get to it then. It says, what is an equation of the graph for y equals x cubed under a vertical compression by a factor of a half followed by a reflection across the x-axis, then a horizontal translation 3 units to the right, and then a vertical translation of 2 units up. So they just went through and showed you the step-by-step process here. So we multiply it by 1/2 to make a compression, which makes sense, right, everybody? We're all good with that? Are reflecting it over the x-axis, we're going to multiply by -1. So that would put us a reflection over the x-axis, and then we're replacing x with x minus 3 to translate it 3 units to the right. So it'll be x minus 3 cubed, and then we're adding it 2 units up, shifting it 2 units up. Okay. So everybody sees how to do this? Okay, sweet. So let's do this one really quick. It says determine the cubic function that is obtained from the parent function y equals x cubed after each sequence of transformations. A vertical stretch by a factor of 2. So won't that be y is equal to 2 times something? I'm going to just, right, we're multiplying by 2. And then it says a vertical translation of 4 units up. Okay, so I'm going to have a plus 4. And then a horizontal translation of 3 units left. So I'm going to have x plus 3 cubed, correct? Left, so left would be negative from the origin, so we go opposite, so plus. And then we have the vertical translation 4 units up, so plus 4. Does everybody see how I did that? We're all good? So vertical stretch by a factor of 5/3. So y is equal to 5/3, and then I'm going to do my left and right shift. Horizontal translation of 3 units right, so that'll be x minus 3 cubed, and then we have vertical translation of 4 units down, so that's minus 4, and then was there a reflection across the x-axis, so that's negative in front. Does everybody understand? Okay, do problems 1 through 4, go. Oh, I'm freezing. Okay, so for number 3, you go through your process, you have a vertical stretch by a factor of 1/3, technically a compression, right? So we have y is equal to 1/3, and then let's continue to read. It says a reflection on the y-axis, that's when you have negative x cubed, not negative in front, but negative x cubed. That's a reflection over the y, because your x's will just be opposite, but your function will be the same. And then we have 6 units up, so plus 6. Everybody good with that? Anytime you're reflecting over the y-axis, you plug in negative x wherever there's an x. Okay, let's move on. Okay, so recall when solving the quadratic that is a transformation from the parent function, we have to account for positive possibilities and negative possibilities. So what squared equals 16? Isn't that 4 and negative 4? Guys, everybody? So then when solving with the square root, we will have 2 answers. So if we had something like this, and we were solving, we would square root both sides. So we would have x minus 3 is equal to plus and minus 4, correct? And then we would solve. So we would have x minus 3 equals 4, and we would have x minus 3 equals negative 4. And then we'd solve, right, everybody? Okay, so, but, with odd roots, such as cube roots, fifth roots, and so on, we'll have only exactly 1 root. And I noticed a lot of people kind of got that confused on the test. What cubed equals 8? 2. Now, negative 2 does not equal 8. So do you guys see how this will not have 2 solutions? Something cubed will only have 1 solution, 2. So if I said to you what cubed equals negative 8, it would just be negative 2. Do you all understand that negative 2 times negative 2 times negative 2 is negative 8? Well, if that's true, then when solving, yes? No, this is odd roots. They have these, this 2, no, there's no i's with odd. That's why we're talking about this. So these have exact solutions. You can take the cube root of a negative. Yeah. So right here, so when solving with the cube root, there's exactly 1 solution. So if we were solving this, wouldn't we take the cube root? Everybody? Cube root. Cube root. So guess what? The cube root cancels out with the cube. So we have x plus 3 equals, what's the cube root of 8? 2. Okay, awesome. And then we'd solve for x. Do you see how that only has 1 solution, everybody? Not 2. Look right here. We would cube root both sides. Cube root both sides. Root cancels out with power. We have x plus 3 equals negative 2, correct? Isn't that the only answer? Yes. So then we would solve for x. So do you guys understand that? Odd roots have exactly 1 solution. Even roots, yes, we account for plus and minus. Odd roots, no. Okay, so what's the cube root of 1, guys? What's the cube root of 27? Yeah? Not necessarily, no, it means that'll be our only solution, so our other 2 solutions usually are imaginary. So the cube root of negative 1 is what? What's the cube root of negative 27? Okay, just making sure that we understand that. Okay, so good question right here. He was just asking, so if you're finding the zeros of a transformed cubic function, how many solutions are we going to have? So isn't this the form of a transformed cubic function? Everybody, are we listening still? So if I was to solve for x algebraically, wouldn't my first step be to subtract k from both sides? Yeah. Okay, then we would divide by negative a, correct? Everybody, you see how I'm using algebra? Yeah. So then isn't a negative divided by a negative a positive? So we have k over a, then when we take the cube root of both sides. Okay, now we know the cube root only has one solution, correct? Right? So we have the cube root of k over a, and then the root cancels out with the power. So then our last step would be to add h. So there will only be exactly one real solution for cube roots that are of the form of a transformed cubic. The other two solutions would be imaginary. Okay. So what are the real zeros of this function? So we have y is equal to 3, I'm going to write it bigger, x minus 1, cubed plus 6. If I said to you, what are the real zeros? So don't we want to know when the function is equal to 0? Right? Okay, awesome. So I'm going to erase this y equals, and now we're going to use algebra to get x alone. So we're going to subtract 6. So we have 3 times x minus 1 cubed is equal to negative 6. Is everybody following me? Divide by 3. So we have x minus 1 cubed is equal to negative 2. Is everybody good? To undo the cube, we'll take the cube root of both sides of the equation. So we have root cancels out with power. We have x minus 1 is equal to the cube root of negative 2. Is that a decimal? Yes. So we want exact solution. So leave it as the cube root of negative 2. Does everybody understand? And I have one last step to get x alone. What will I do? Add 1 to both sides. Add 1. So x is equal to the cube root of negative 2 plus 1 is my solution. Now that's an exact answer rather than a decimal answer. Does everybody understand? That's why I'm not simplifying it anymore, because if I did, it's going to be a big long decimal. This is exact. Are we all good with that? Don't say it's imaginary. The cube root of negative 1 is just negative 1, right, everybody? So this isn't imaginary. Odd roots aren't imaginary. Okay, let's do maybe just, do we need more, or do you feel pretty good? Maybe one more? Okay, let's do this one. I don't care. Which one do you want to do? This one with fractions or just whole numbers? Okay, awesome. Just have your calculators ready to go. Here we go. So we'll set it equal to 0 and solve. So won't we first subtract 8/9? Subtract 8/9. So we have negative 3 times x plus 4/5 cubed is equal to negative 8/9. Is everybody feeling good? Now we would divide by negative 3. So we would have x plus 4/5 raised to the third power is equal to, dividing fractions is easy as pie. You flip the second fraction and you multiply. So that would be times by 1 over negative 3. That is a neat little trick, right? So when we get negative 8, guys, you'll want to watch this one because I'm going to show you what I will expect from this. So won't that be a negative 8 over negative 27? So can I just write 8 over 27? Right? Negative over a negative. Okay, awesome. 8 over 27. From here, won't we cube root both sides of the equation? Good, I like that you said that. So we have x plus 4/5 is equal to, yes, you can split that up, and you get the cube root of 8 over the cube root of 27. So we have x plus 4/5, I'm showing my work, is equal to, the cube root of 8 is 2. The cube root of 27 is 3. And then our last step will be to subtract 4/5, correct? Are we all following me? So we have x is equal to 2/3 minus 4/5. And that one you could actually calculate. I don't want to have to get a common denominator, so somebody just do it in your calculator. Hit math, enter, enter. Let's just make it easy on ourselves. Do you guys all know how to do that in your calculator? Okay, what is it? Negative 2/15. Sweet. So there's our one solution. Any questions?
Wait, what do you mean by doing
2/3 minus 4/5. And then change it back to a fraction. Okay, well, you guys are behind in the game here. Okay, awesome. Okay, what I want you to do is numbers 5 to 10, ready, set, go. So what we established before lunch is that we can take something cubic and we can write it as a transformation and it looks something like this, correct? Everybody, and if that's true, if it has this form, we've established that there will only be one single real zero, correct? Now think about it. There are cubic graphs that have more than just one real solution, such as this picture. So if that's true, if we have a cubic that crosses the x-axis 3 times, then it cannot be written as a transformation of x cubed. So if you ever have a cubic with 3 solutions, it can't be written as a transformation. Does everybody understand? Okay, so only if it has this form and can be written as a transformation will it have one single real zero. So that's also true for some quartic functions. Some quartics are simple transformations of a parent quartic, but there are some quartics that are not. So we're going to get to that example. Okay, so it says, right up here, it says, what's a quartic function with only 2 real zeros at x equals 0 and x equals 6? So the parent function, if you typed it into your graphing calculator, parent is non-shifted. Y is equal to x to the 4th. It looks something like this. That's not a perfect picture because I had to draw it by hand and I redrew it like 10 times trying to make it look right. Anyways, it kind of looks like a parabola, but it's not, right? It's degree 4, so it's a little bit more spread out. Now that's just the parent function of x to the 4th. So it says, what's a quartic function with real zeros at x equals 0 and 6? So let's say that this is over to 6. So this is 0, 6. So we know it's crossing the x-axis through there, right? Everybody? So it's going to look something like this, kind of, okay? Now, here's the thing. We know that before this was moved over here, it was symmetric over the origin. Before we shifted it, because we've shifted it right and down some, right, everybody? We're not exactly sure where. So before we shifted it, weren't we at, if we wouldn't have shifted, wouldn't halfway between be 3? Everybody understand? So before we shifted, we were at -3 and 3. So now let's figure out how far down we need to be so that our zeros will cross through -3 and 3. So if you think about it, we need something to the 4th be equal to something that will give us, when we take the 4th root, a solution of 3. Does everybody understand what I'm saying? So wouldn't we just do what's -3 to the 4th power? What is that? It's -3 to the 4th power. 81, right? We get 81. And isn't +3 to the 4th 81? So we know that this question mark needs to be 81. We need x to the 4th be equal to 81, so that if we took a 4th root, we would get plus and minus 3 as our solutions. Does everybody understand? So if you think about it, before it was equal to 81, wasn't it set equal to 0? So we would subtract 81, subtract 81. So we have x to the 4th minus 81. So that means we're as far down as 81. So this is as far down as 81, so I'm not drawing it to scale. Does everybody understand why? So that it will cross. But now we've shifted, we've gone from -3 up to 0, we've gone 3 up to 6. So what was our solution? So what was our shift right? Right 3. Does everybody see how from -3, we now shifted over to 0? So, and then we went from 3 to 6. So we shifted right 3. So we took this and shifted it right 3. So that would be x minus 3 to the 4th, and then minus 81. Now you could check your answer, solve that, and if you get plus and minus 3, plus and minus 0 and 6, if you get those solutions, you've done it correctly. Does everybody see how I wrote that? That's one way of doing it. So I'm going to ask you a question. Does the quartic function -f of x have the same zeros? No. So, no, -f of x is a reflection over x, right? So wouldn't it have the same solutions, guys? It would just be flipped upside down, right? Flipped over x. You're confused? Did I hear that? I swear I heard that. Okay. So let's do number 11 on the worksheet. It says, find a quartic function with the given x values. So we know x is equal to 2, and we know x is equal to 8. 2, 3, 4, 5, 6, 7, 8. So those are our two solutions. Now, before it was shifted, weren't we at 0? We were symmetric about the origin. So if you think about it, my axis of symmetry is halfway between those, correct? So from 2 up to 8 is how much distance? 6, guys, right? So cut in half would be 3. So 1, 2, 3. 1, 2, 3. I didn't draw this very good. 1, 2, 3. Okay. Awesome. So we were at, beforehand, we were at, once again, -3 and 3, correct? Before we shifted it. Does everybody understand? So we need to know how far down it goes. So we know it's a quartic. So x to the 4th equals what? Will give us the solutions -3 and 3. Don't you just plug in -3 right here? So wasn't that 81? So -3 to the 4th is 81. So we know x to the 4th equals 81 will give us these solutions. If we took the 4th root, we have to account for plus and minus, so it's an even root. So anyways, now we know it's x to the 4th minus 81 equals 0. All right, so that's starting us off, and now we've got to say how far did we shift? So we used to be at -3. We've now shifted over to 2. How many units is that? 3 this way, right? Then 2 more. Isn't that right? 5, everybody. So our final answer would be x minus 5 to the 4th minus 81 equals 0. Now if you were to solve that, you would add 81, take the 4th root, put the plus and minus, add 5. You better get solutions +2 and +8, and you would. So we just know that it's a 4th degree, so it looks something like this, but we don't know how far down to go. But we need to know how far down this needs to be to give us these solutions. So we just plug in 3 to the 4th here, so that if we take a 4th root when solving, we'll get these solutions. So 3 to the 4th is 81. -3 to the 4th is 81. So we know that we need this to be 81 so that we get those solutions when we solve it. Does that make sense? Okay, so let's do it another way. It says, let's do number 12 a different way. Yeah, because we took it, this was our original, we took it and shifted 5 over, and then this was at 81. Okay, so over here, let's do it different. It says, write any quartic with these as the only real solutions. So we have x is equal to 3, we have x is equal to -1. I'm going to say x is equal to I, and x is equal to -I. Won't those be imaginary solutions? Guys? So won't we only have 2 real solutions for this? Okay, so let's work backwards. So we'll have an x minus 3 equals 0. We'll have an x plus 1 equals 0. We'll have an x minus I equals 0. We're just working backwards. We're using a different method for this one. Do you see what I'm saying here? So then we have x plus I equals 0. Before they were split apart, they were multiplied together. So we had x minus 3 times x plus 1 times x minus I times x plus I. Now we'll put it in standard form, multiply 2 of them together, combine like terms, multiply these 2 together, combine like terms, and then multiply the full thing here. So this is going to become x squared. I'm going to skip steps because I know you know how to multiply a polynomial. So this is going to be x squared minus 2x minus 3. This, if we multiply it out, is going to be x squared plus 1. And then from there, we would double distribute. So we'll get x to the 4th, and then minus 2x cubed minus 3x squared, and then we'll have, I already did that, sorry, I'll do that, plus 1x squared, and then minus 2x, and then minus 3. So then combine like terms, x to the 4th minus 2x cubed, and then we have negative 3x squared plus 1x squared is minus 2x squared, minus 2x minus 3. This polynomial also has only those 2 real solutions. It's just a different method. You can use either or method, so I'm going to have you do half of them one way and half the other way. Which way do you think is easier? They're easier in different ways for different reasons, I think. Do you think number 1's easier? Really? See, I always think this one's easier.
Yeah.
Yeah. Negative. Okay.
Wait, so why do you choose negative?
Because those are imaginary solutions. And if you have one imaginary solution, its conjugate has to also be the other solution. So I could have used 2i and negative 2i. I just chose I because that's easy, which so is 2i. Your polynomial could come out a different answer. Do you get what I'm saying? There's not exactly one answer for these. So you could have used 4i and negative 4i, but it would just be bigger. Yes. No, because then that's technically 4 real solutions. And this says only 2 real solutions. So that's actually a good question. So do 11 through 19. Odds do the first method. So on odds do the first method, and on evens do the second method. Your polynomial doesn't have to be the same as your neighbor's a lot of times. Because you don't have to use I and negative I. I just use those because they're easiest to me. Does everybody understand what they're doing? And I can pull up that example for you to look back onto. We're good for a minute? Okay. Okay, so everybody look up here for this next part. So if we're looking at a cubic function, here's the parent function. These are known points. You could find these by plotting it or graphing it in your graphing calculator and pulling up your XY chart. But I'm just giving it to you. So I want you to look at these pictures and let's determine the transformations that were used to change the graphs from the parent function. This is definitely something that you could see more on an ACT and on a end-of-level testing. So let's look at this one. So if we have our starting point at 0, 0. Then we're at a point over 1, up 1, and then over 1, down 1. Does everybody see that on the parent function? Yeah. So I have a parent function up here. So I always use the parent function to then look and determine the shifts. So are we shifted, this point that used to be at 0, 0, isn't it shifted back 1, up 4? Everybody. Left 1, up 4. So wouldn't that be y is equal to x plus 1 cubed and then plus 4, correct? Yeah. Now we've got to look and see before we put the y in front if there's a stretch or compression. So isn't that point still just a difference of up 1 over 1? Everybody? Yeah. Right 1 up 1, isn't that putting us just 1 point above this? Yes. Yep, so there's no stretch or compression here between negative 1 and 0, between those first consecutive points. So that would be my answer. There's no stretch or compression, so we're good. And notice it's not reflected, it's still going like this, so there's no reflection over the x or y. Here we go. 21. So looking at it, our starting point is at over 1, up 1. So that's right 1, up 1, correct? Everybody, are we seeing this? So then we're going to have x minus 1 cubed and then plus 1. Am I correct? So now here's where it's a little bit tricky. So like Mr. Roberts would have you go through and say, okay, so we know that y is equal to a times x minus 1 cubed plus 1, correct? And then use this new point 0, 3 to find a. So you could do that, or you could just think about it, but it is a little bit harder to think about. Before this was shifted, wasn't it 0, 0, this 1, 1? So how did we get to 0? You got to compare it from the original position for acceleration. So from 0, 0, we went down, we went left 1, down 1, correct, everybody? So this one would need to go left 1, down 1. It's almost easier just to do this, because I don't want to I don't want to confuse you. You want to just do this so I don't confuse you? Okay, let's just do that. So let's plug in 0, 3. So this is an xy point, correct? So we would have 3 is equal to a times 0 minus 1 cubed plus 1. Now it's just algebra solving for a. I like algebra, or you could compare. You see what I'm doing here? Okay, so let's solve for a algebraically. So we have 3 is equal to a times, isn't this negative 1 cubed plus 1? So we're going to have 3 is equal to a times negative 1 plus 1. So when we subtract 1, people, minus 1, we get 2 is equal to negative a. So we'll divide by negative 1, divide by negative 1. So we get a is equal to negative 2. So we have negative 2, and then a, and then we have this function. Now notice that negative was our reflection over the x-axis. Do you see that? Because it was a times negative 1. Negative 1 cubed is negative 1. Right?
Yep.
So algebraically is almost the easiest way. Instead of just trying to think about it, you might get it wrong. And you see how that took care of my reflection? It used to be, look at the original. Original looks like this. You see how it was reflected over the x-axis. Now this comes up here, this is reflected down. You see it, everybody? But if you do the A like this, then you don't have to worry about it. Does everybody see that? Let's do one more. So looking at this one here, we're shifted right 3 down 2. So that'll be x minus 3 cubed, and then down 2, minus 2. So now we know that cubics have the form y is equal to a times x minus h. Our x minus h is x minus 3 cubed, and then minus 2. Now plug in the other xy point, so I'm going to plug in that point because it's consecutive with this point. You see what I'm saying, everybody? Consecutive means one comes right after the next. So we know this is an xy point. Let's put in x and y. So that'll be negative 3 is equal to a times x, not x. What is x? 4. So we'll have 4 minus 3 cubed minus 2. So let's solve for a. So we have negative 3 is equal to a times 1 cubed minus 2. 4 minus 3 is 1. 1 cubed. So won't we add 2? So we have negative 1 is equal to a times 1. So isn't a negative 1? Everybody? Yes. So we would have negative 1 or negative f of x. There we go. That way you don't have to really think too hard about, well, what did it used to be? And then we only went down by a point and we reflected it. Anyways, this is just the algebraic way of solving it. Does everybody understand? Are we confused or what? Okay. Then I want you to quickly do those three for me then. Answer in your groups. They're not on your paper, but Mr. Roberts hands these out to his students on the way out the door. And I don't do that, so I'm expecting you to do these. Not on. Ready, set, go. On the whiteboard. Okay, here we go. So it says, determine whether each function can be obtained from the parent function. Y is equal to x to the n using basic transformations. If so, describe the sequence of transformations. So looking at number 16, we would say yes, because this does look like a transformed cubic, except for it's not shifted left and right, no shift up and down. There is a stretch of 4. Are you guys watching? Stretch of 4, and then it has a reflection over the x-axis. Does everybody understand why? Okay, so looking at this one, x cubed minus x, that cannot be written as a transformation from the parent function. It doesn't have the correct form. That minus x in there throws it all off, so we would say no. Does everybody understand? We cannot write that as a transformed cubic. Does everybody understand? That was like, because remember how we talked about the cubics that have 3 solutions cannot be written as the transformation. Okay, looking at this one, we would say yes, because it is a quadratic just transformed. So we'd say yes, and it is right 3, up 5, I'm not going to write it, and a stretch of 2. Is everybody good with that?
Yeah.
Okay, looking at this one, x squared minus 8x plus 7. A lot of people will say no, but can't all quadratics, can't we complete the square? Everybody? And then write it as a transformed quadratic. So quadratics can always be written as a transformed quadratic. So this one we would go through the process of completing the square, and then we would say it, but I'm not going to take time to do that. So recall, all quadratics can be written in vertex form by completing the square. So all quadratics can be written as a transformation from the parent function. So if you ever see a quadratic, it can always be written as a transformation from the parent function. However, cubics can only be obtained from the parent function if it has the correct form. And same with quartics. Some quartics cannot be written as a transformation of functions. Only the ones that have the correct form. Okay, so you're going to finish the worksheet, which there's a lot of homework today. Sorry, I did my best. Short day. That just happens sometimes.